everyone. Welcome to Reason with Science. I'm your host Jitendra. This episode is with Martin Rees. Professor Rees is a cosmologist and astrophysicist at Cambridge University and co-founder of the Center for the Study of Existential Risk. He was president of the Royal Society. His latest book is On the Future Prospects for Humanity. In this conversation, we talk about the evidence for Big Bang, aliens, threats to humanity, space travel, and how to envision the future of humanity. Enjoy the conversation, share, and subscribe to support the podcast. Thank you for listening. Hi, Martin. It's a great pleasure to talk to you. Welcome to the podcast.
Thank you for the invitation.
Yeah, so we'll talk today about your last book, which is On the Future Prospects of Humanity. But before we talk about future, let's speak a little bit in the past as well, like how much it has changed and how fast it is changing for humanity.
I make my point in the book that this century is special. It's the first century when humans, one dominant species, have the future of the planet in their hands, because we are more numerous than in the past, we're more demanding of resources, and we have more advanced technology. And so what happens this century could make a difference to the entire planet. And this is something quite new. We can have a disaster which cascades globally and is irrecoverable. So that's why this century is very special.
Yeah. So, and when we say that this century is special, what is so special in it? I mean, so in your book, basically, you talk mainly about science and technology and their contribution in the society. So let's start from that. So what or how important is science and technology today for humanity?
Well, it's been our salvation, because the real answer to your question is that this is the first century when there are enough humans to really have an impact on the global environment. The population now is almost 8 billion, and that's doubled in the last 50 years. And we're all using more resources. So what's changed in the last 50 years is that we are more demanding of resources and of energy. And that's why we have to worry for the first time about feeding everyone and about climate change. So these are new, and that's really because of the fact that there are more of us. And that's why we need science, because science does cause some problems, of course, but it also is something which can be the solution to these problems.
Yeah, so that's more like an optimistic view on science. And what would your response will be for the people who kind of go against science and then say that we don't need science, basically?
Well, I think to make one point, for instance, that the world population's doubled in 50 years, and had it not been for the Green Revolution, there'd be far more starvation now than there actually is. I mean, of course, there is starvation, but it's due to maldistribution and political problems and war, not to overall scarcity. So we've got benefits of technology. And of course, the other point I'd make is that the fact that you and I can speak to each other, and perhaps the fact that even in the middle of Africa, they have mobile phones and are in touch with the world. These are huge benefits from technology. And the fact that life expectancy in most parts of the world has gone up, infant mortality has gone down. All these things are the benefits of science. So I don't think one can decry the benefits of science. But one point in my book, though, is that because we are more empowered by science, then bad actors, as it were, can do more damage through science. And so the stakes are high, that science can be misused.
Indeed. So basically, there are two perspectives here when we talk about science for society. One is as in like worldview. How do we exist? What is the reason behind it, or how do we how we are linked with the other species,
Yes.
with the universe itself? And the other thing is the facilitation part where we kind of talk about new technologies, how new technologies we can develop to survive longer, or to kind of increase the life or improve the life of humanity, right?
Mm. Yes. Well, of course, that's right. It's traditionally been said that science is a pure inquiry, and the applications of science then translate into things of human benefit and engineering and technology. That's true to some extent, but that's oversimplified because it goes the other way. Um, I'm an astronomer, and the advances in astronomy come from the fact that we can use new technology to do better science. And so there's really a symbiosis between advancing technology and instrumentation and computers, etc., and science. So obviously, science, quantum theory, and all that is the basis of much of modern technology. But we wouldn't have advanced our science as we have in the last 50 years had it not been for those technologies.
Yeah. And so there is, I mean, of course, a small point, but I think it has become quite an important once we listen to different conversations and science communication. We see that there are many debates on science and religion. So how that important, like what is the importance of those?
Yes. Well. I mean, of course, uh, there are some religions which lead to a sort of contradiction of science. I mean, if you think the world started 6,000 years ago, I think that one can show that that can't be true. But my view is that there can be, in general, peaceful coexistence between the various religions of the world and science. There are many people who hold different religious beliefs among my colleagues, and I think we should accept that. We don't really want a standoff between science and religion.
So there is one interesting thing here, which is Copernican revolution, because I think that's basically started changing our worldview in general. That the Earth is not centered in center of the universe. It's
Right?
the
Yes.
sun, which is center of the solar system.
Yes. Yes.
Um, so, what's your view when it comes to this kind of evolution of our thinking, which again comes from science?
Well, I think speaking as an astronomer, the main thing that's happened is an ever grander concept of how wonderful and mysterious and vast the universe is. Um, uh, 500 years ago, we had Copernicus who said that the Earth was not the center. But then we've learned since then, uh, uh, I would say three and perhaps four further Copernican revolutions. We've learned that our sun is just one of billions of stars in the galaxy. We've learned that our galaxy is one of billions of galaxies. And um, we've learned that many of the stars have planets around them, just as the sun has the Earth and other familiar planets. And further speculation is that maybe our Big Bang, which started the universe we can see, is just one of many. So we are um, moving towards an even vaster concept of physical reality than our ancestors had.
So when we think of these kind of grand concepts, we actually realize that we are made of those really basic, simple particles, which are, I think, less than 100 or
Yes, yes,
so.
yep,
Um, and so basically that also shows that we are part of this grand universe.
yes,
It's not like we are something special.
yes,
We are special in terms of complexity, which we should
that's right.
talk about in a way that the human brain is so far the most complex thing known to humanity.
Yes, yes.
um, so let's first talk about our place in the universe, and also then we can talk a little bit about complexity.
Yes. Well, I mean, as you say, we are the most complex things that we know about in the universe. Our brains are the first entities that have been able to understand, to some extent, the universe and ponder the wonder and mystery it presents. And of course, we also understand that, as you say, we are made of the same um, substances as the rest of the physical world. And indeed, we've learned that the cosmos, which used to be thought by the ancients to be made of quite different stuff from the Earth, is made of the same atoms. The spectra of a star show it's got the same atoms in it as we have. So we've learned that the basic building blocks of everything that we know about are the same. And we know that through the marvelous process of Darwinian evolution, simple life, nearly 4 billion years ago on our Earth, has evolved into the complex biosphere we see around us and of which we're a part. And we don't understand, incidentally, how the first life started, but we do understand, at least in outline, how the evolution took place from simple life to the various kinds of complex life. But let me mention one thing, which is perhaps a special perspective which astronomers bring to this. Most people are aware that we're the outcome of this multi-billion year evolution by Darwinian selection. But I think most people tend to think that we are the culmination of that. We're the top of the tree. And I think no astronomer can believe that, because although we are aware that the sun has been around for 4.5 billion years, we also have strong reason to think it'll go on for 6 billion more years. So it's less than halfway through its life, and the galaxy will go on still longer. And so, one important idea I try to propagate is that we humans are a critical stage in the emergence of intelligence and complexity in the universe, but we are not the end of it. And so, in 5 billion years, there could be entities in our galaxy very different from us, as different from us as we are from slime and mold, for instance. We just don't know. And so we can't conceive what may happen in the future, but we are an important um, transition species, clearly.
Yeah, well, one of my favorite questions, at least nowadays, is and which also kind of troubles me, the like how complexity arises from matter.
Indeed, yes, yes.
So what's your take on that?
Um, well, I mean, we can just study the details of how it happens, and um, there are some stages we don't understand, but we do understand, for instance, how starting from a very simple organism, the accumulation of small advantageous changes can lead to Darwinian evolution. So we can actually see how over vast amounts of time it's possible for complexity to enhance. Um, and we don't understand all the details, but we can understand or see how it happened.
Yeah, so it's a bit troubling to kind of or once we think that the so of course if we look at the hierarchy, I mean, of course it's still a bit fluidy in a way. um that there is a transition from physics to chemistry to biology in a way that the complexity increases.
Yes, yes.
And the fact that this because at the lower level everything seems so deterministic, but then once we go up the ladder, we realize that there is some autonomy in a way, that we feel that there is this free will kind
That's
of
right.
kind of
Yes,
thing,
yes,
right?
yes, yes. Which we don't understand. But of course, even at simple levels, things aren't very deterministic. I mean, you can't forecast the weather more than a few days ahead. Tiny changes in the initial conditions can make a big difference. So there's not very much which is predictable very far ahead.
Yeah, this was really fascinating example for me once I read it in your book, that the so for example, predicting weather should be really simple if it's simple particles, but it seems like that there is something more going on, and that's why we are not able to do it. But is it because of computation, or it's something more?
Yes. Well, I mean, it's really that small small changes amplify. I mean, to take an even simpler example, if you take the game of snooker, where you have balls on a table, it would be impossible to predict for what happened after more than about 30 or 40 collisions, because the effect of the gravitational pull of one electron at the edge of the universe could make a big difference. So the point is, tiny, tiny changes can have more and more effect as time goes on, and so that's a very simple example. But that's why weather prediction is limited sometimes. I mean, you could predict it's going to be hotter in the summer than the winter, of course. But some of the details do depend on a tiny fluctuation.
Exactly. Yeah, this is also again a great example. So when we are talking about all the, I mean, so far we kind of briefly introduced the humanity itself. It's really brief kind of examples that how the simple particles can give rise to something so complex as humans. Interestingly, of course, we have existed for thousands of years now,
Yep.
but we didn't have those kind of tools to understand, to evolve in a way to facilitate humanity, but also we didn't have tools to understand our impact on biosphere, which now
Right.
we have, and we understand how we are impacting and how we are evolving to certain extent.
Right.
So
Mm-hmm.
let's talk about the existential risks. First, like, would we go on extinction because of natural calamities, man-made crisis, or I don't know, some alien civilization?
Um,
Uh,
well, we can conceive of a context where we could become extinct, and extreme climate change in thousand years, for instance, might make it rather hard for humans to survive. But if technology advances, then we could cope with the change. So maybe we can cope with even drastic changes. So there are changes, but the main thing which has changed in the last 20 or 30 years, and this worries me, is that for the first time, all the world is interconnected. I mean, in the past, there were society collapses in particular countries or continents, but they didn't spread globally. Whereas now, if there was some real collapse of society in one part of the world, but we're so interconnected by communications, travel, supply chains, and all the rest, that would be a setback for the entire world. And so this makes us more vulnerable, I think. And and this is what worries me. And this is the misuse of technology.
and one example would be a recent pandemic where, I
Hmm.
mean, if this would have been in the past, it might have been located only at one part.
Question. Yep, yep.
But this now, because of globalization, it was easy for a virus to spread
Yes, yes, yes,
all
yes.
around the globe.
And that makes it worse. And of course, the good news was that SARS allowed us to get vaccines, but you could imagine a worse pandemic with a high fatality rate, which we couldn't cope with.
Yeah. And so, how good our consensus is on climate change, on man made climate change?
um, well, the details are uncertain, but I think what is completely clear is that the carbon dioxide concentration is going up, and that is in itself causing warming. But then there are various feedback effects which may amplify it. So the actual details are, of course, very uncertain. It's a complicated thing to model, but I think we can be confident that as the carbon dioxide concentration rises, and it's gone up by 50% since pre-industrial times, then there will be more um, warming, but more importantly, there will be uh, shifts in the global weather patterns. You know, where the droughts occur, where the monsoons occur, and things like that are going to shift. And so I think the disruptive effects of climate change are hard to predict in detail, but they could be serious. It's not just that the temperatures are going to rise by 2 or 3 degrees; it may be worse than that.
And when it comes to the solutions of it, I mean, of course, there are many solutions, and we can kind of talk about over and over. But what do you think? What is the major problem? Is it are we not able to kind of conceptualize that what can be problem in the future? Like we are not that much future oriented, or is it something about policy making itself?
Well, it's both those things. It's that politicians and the public tend to think about immediate problems and not long-term ones. But secondly, there is a big technical challenge because if we are going to get all our power from power stations that don't burn fossil fuels, sun and wind and other things, and maybe nuclear, then that's going to be a huge transition. And uh, so to move towards an economy where we don't depend on burning fossil fuels, coal and gas, is very difficult, especially for countries like India. And I think the biggest challenge is that uh, it's not going to be enough for the wealthier countries of the global north to make that transition. They've got to make sure that the countries of the global south, which actually need more energy than they have now, because they're not using nearly as much as us, they've got to be able to leapfrog directly to clean energy, just as they have leapt directly to mobile phones and never had landlines. So the important thing is that the world has to make sure that the developing countries don't go through a phase where they depend on lots of coal and gas power stations. And this has to involve collaboration with the countries in the rich northern world, which, of course, they've caused most of the problem, but they may help to come up with a solution.
And the this can be the advantage of globalization, just because now we are more connected, we can
Well,
be kind of
indeed,
more understanding in that way.
yes, and I think I'd like to think that there will be big companies and research centres in India and Africa which collaborate with those in the north, which prioritize developing cleaner and more efficient sources of energy. And that's what we need. That's a top priority.
Yeah, so apart from, I mean, of course, this is one of the recent conversations, debates which are going on climate change. But apart from that, two other interesting topics. First is the genetic engineering,
Yes.
which is modifying now or start modifying the genomes or DNA of the individuals. And the
Mhm.
second one is the AI, artificial intelligence.
Yes, yes. Mhm.
So let's start with the first one, with the genetic engineering part itself. So
Yes.
do you think it's, or do you think we should be alarmed about it?
Um, well, I mean, I think in some limited cases, it's clearly a good thing. I mean, the gene editing of plants to make them more resilient for CRISPR-Cas9, I think this is entirely acceptable. Um, uh, More acceptable than old style because it doesn't involve getting genes from one species to another. It just involves tweaking the genome of a particular kind of plant. And I think everyone would say that if there's a human disease like Huntington's disease, which is caused by one gene being wrong, then if we can actually deal with that, that's fine. But if it comes to something where we're trying to modify or redesign humans, I think we've got to be very, very careful, and we should not encourage that.
So just for the general public, I mean,
Yes,
because they may not understand what is genetic engineering or
yes, yes.
CRISPR-Cas9 is,
Yes.
their point would be that we have just mutated even the food. Food is not like the real food; it's modified food or some in some way, and then they don't know what will be the long-term impacts of that. So how we can assure them that it's fine to use these products?
Well, I think we can just say that um, the DNA and double helix in a plant it's varying all the time through natural variations and mutations. And if we can make a particular change, which is targeted to do something good, then I don't see anything wrong with doing that. And that's something which you can do. But the idea of changing human beings, except in cases like Huntington's disease, when it's just one gene, they are, I think, more worrying because most of the features of humans are due to a combination of genes, many thousands of them, etc. And uh, even if you could change those many thousands, there may be some downside. So I think for all kinds of reasons, we are right to go slow. But I think the caution in not even allowing gene editing of crops was excessive caution, and so to do that, I think is fine. But enhancement of human beings by massive gene changing, I don't think it's a good idea. To digress slightly, in another book I've written, I've talked about whether one day there will be people trying to live on Mars, and if there are, then I think we should wish them good luck in doing this sort of thing because they're away from the regulators, who we hope will stop um, genetic changes into humans, and of course they're in an environment very hostile to humans, wrong atmosphere, wrong gravity, etc. And so they're the ones who will probably be motivated to change their genetic code, but leave it to them.
Yeah. So, I mean, in general, the simple point would be that this process, it happens naturally. It's just that
Yep.
we, with genetic engineering, we kind of speed up the process in more directed fashion. That's the
Yes, or just make just one tiny
exactly.
change which does something which we can predict and which we know would be helpful. Yeah.
Exactly. So, in the same way, when we are talking about speed up the process,
Yes.
another process is the artificial intelligence part,
Yes. Yes. Yes.
where we are trying to speed up the process in a way to increase our problem-solving capacities and also abilities. So, what what issues should we be consider there in terms of our future?
Well, we've got to be careful. I mean, I think it's clear the advantage that AI has is that the computers can process data much faster. And so for dealing with traffic flows in a city or electricity grids, for instance, then an AI system can do better than humans. And incidentally, I think if the Chinese wanted to have a fully planned economy, they could have one that Marx could only dream of because they would have all the data on um, inventories in every shop and transactions and all that, so that they could do that. But I think there's a real danger in uh, handing over to AI decisions which really ought to have a human in the loop. I think, for instance, in medicine, um, AI can do some good things. I mean, for instance, it's already known that if you've got lung cancer, then a machine can scan your lungs and give a better um, prognosis of your cancer because the machine can have looked at 10,000 different X-rays in a few days, whereas no human doctor can do that. So machines can certainly help with diagnosis, but I think uh, we've got to have a human in the loop um, because there may be some bug in the program, and we don't want to leave important decisions like whether you're sent to prison, whether you have an operation, etc., just to a machine. You've got to have a human in the loop, I think.
Yeah. So, but in your book, basically, you say that the future of humanity would be more like silicon based. That there'll be more kind of robots, and it may be that robots may take over humanity. Is it possible?
Well, I mean, that's the very far future. And as you know, some science fiction writers talk about that. It could happen. I mean, my scenario is that that won't happen on the Earth, but that may happen if there are communities trying to live in space, and they will use all these techniques because they've got an incentive to adapt. And so I think it is possible that there will, in the far future, be entities in space which are mainly electronic rather than flesh and blood. And of course, if there's another planet which had a head start over the Earth, then those entities may be out there already. So if we are looking for evidence of intelligence in space, so-called SETI techniques, then my estimate is that we're more likely to find something like that than something which is a flesh and blood civilization like what we have on the Earth today. I think that's certainly a possibility in the far future of going from a cyborg where we plug in a bit of extra memory to something which is purely electronic, because there must be some limit to the processing power of the flesh and blood in our brains, which is so much slower, of course, than the electronic. And so maybe the electronics will take over.
So do you envision humans on another planets, like beyond beyond Earth, or you envision robots taking over and kind of, colonizing on other planets?
Well, I mean, I think the 2 points. This could be the far future of life descended from humans on Earth. But on the other hand, there are other planets in the galaxy orbiting stars which are at least 1 billion years older than our sun, and they might have had a head start. So there could be entities which evolved on those planets which already got to this stage. We've no idea, because life could be unique. We don't know if there's life out there, but if there is, then it won't be synchronized with life here. And if it started on an older star or around an older star, then it might already be in that stage.
Yeah, so we won't be able to, you mean, communicate with them or something?
Well, we could, if we could detect something that was not natural, so we could show these existed, but we couldn't really communicate, I don't think, no. Culture gap would be too great. And of course, the time lag is too great, because the nearest these would be many light years away. So no quick repartee, as it were.
Interesting. So even if it'll be, again, it can be simple particles or signals, but still, because of the correlation, it can be so complicated that we may not be able to kind of detect it or understand it.
Right? And may be able to understand it. Yeah.
Yeah. So what do you think about humans exploring the universe? I mean, of course, now we are doing it with the different telescopes.
Yes, yeah.
It's not that efficient, as far as I get it. That still we are looking at these little fluctuations when we are looking for other suns or other stars or other exoplanets, but still we don't have direct probes to kind of take the direct pictures of these distant planets or stars.
Right. Yes. Well, the James Webb Telescope and a big telescope being built in Chile with a 39-meter mirror may be able to get a spectrum from the planets around nearby other stars. Maybe able to do that, but they're so faint that we won't get details. So we need even bigger telescopes than that. But of course, that's easier than going there, because of course traveling to another star is far beyond any present technology. So we will really depend on telescopes. Although we can send probes to all the planets of our solar system, not just Mars, but to the moons of Jupiter, and see if there's any life on Europa or Enceladus, which have ice and water under the ice. So we can do that. But I think it's far easier to send robotic probes than to send humans. And my newest book just out called The End of Astronauts makes the point that as robotics has advanced in the last 30 years, the need for sending humans into space to actually explore or to fabricate structures is getting far, far less. So the only reason for sending humans is just as a exploration, just as a thrill, and so I think that public money should not be spent on sending people. It should be left to the billionaires, etc. If they want to send people into space, then good luck to them. And the other reason for that is that if you look back at the history of human spaceflight, then of course there was the Apollo project 50 years ago to send people to the moon. And since that time, many hundreds of people have orbited the Earth in low orbit, mainly in the International Space Station. And hundreds have been up, and they go up in the shuttle, and there were 2 crashes of the shuttle, and it's not safe, but it was a 2% risk of sending people up in the shuttle, and that was thought too high a risk for civilians paid for by the public. So my view is that human space flights should be left to the private sector and to people who are prepared to accept a bigger risk than that. I mean, people who go hang gliding or exploring or mountain climbing or crossing the Antarctic, they're prepared to accept that risk. And I think if we leave human spaceflight to people like that, prepared to accept greater risks and even one-way tickets, that would be a lot cheaper, and we can cheer them on. So I hope that happens.
Yeah. So, but as a species, or for a species, what do you think? How this space exploration or colonizing other planets can really help? Are we looking for more resources, or it's just like the curious nature of humans in general, or it can be a kind of proxy if something happens to Earth and we just go out there?
Yes. Well, I mean, I think there will be a few adventurers probably living away from the Earth in a few hundred years' time, and that's good. But I think the idea which some people like Musk have had, that we can send millions of people out to colonize Mars and escape the Earth's problems, is a dangerous delusion. Because we talked about climate change and all that, but dealing with climate change, although it's a big challenge, is far, far easier than making Mars habitable. And so there's no planet B for ordinary risk-averse people. We've got to solve the Earth's problems and sustain the Earth's environment in a state for humans without having this escape route. So it's a dangerous delusion to think we can escape the Earth's problems by mass immigration. But on the other hand, there may be some resources we can get from asteroids, etc. But I think for we humans, I think we evolved to live on this Earth, and that's going to be a place where I hope we'll be sustained. But as I said earlier, we are maybe not even the halfway stage in evolution, because there are billions of years to go. And so if we look very, very far ahead, we've no idea. And there may be lots of life out there, and there may be creatures very different from humans who will live out there. But for anything like a human, I think the Earth is a place we should cherish, because we are adapted to it, and we don't want to go to Mars.
The other thing which is really important for us to understand is the fact that we are not so independent. I mean, for food, we are dependent on plants or other animals, for example, which are, I mean, plants are the real autonomous in a way that at least they can, produce their food on their own. And
Yes.
so even if we move out there on some other planet, still we'll have to deal with these basic issues, and still will have to develop that technology to cultivate our food, or to
Indeed,
get
and
all the
that, yes,
resources.
and that reminds me that when we are worried, as I said at the beginning, about humans having an impact on the global environment, on the climate, and biodiversity, it's very important that we don't reduce the variety of life on the earth, because as E.O. Wilson, the great ecologist, said, if this generation causes mass extinction, it's the sin that future generations will least forgive us for, because that's irrecoverable. So we've got to make sure that in cherishing this planet, we not only ensure that the climate doesn't change in a way that's deleterious for humans to live, but also ensure that we don't destroy the habitats of natural animals and plants, so that we reduce the rich variety of nature.
So we don't destroy the habitats, but we need to destroy the habits which are making us destroying those habitats. So I think it's
well, human attitudes will have to change. Yes.
exactly.
Yes.
Exactly. So that's what my question was. So what is a message that you want to give to both scientists and humans, the humanity in general,
Yeah.
thinking in a way that in this billions of years old universe,
Yes. Yes.
and billions of years old this planet, at least one species exists,
Yes.
which is able to kind of ask these questions about its own existence,
Yes. Yes.
and
Yes.
able to thrive in a way, in this kind of environment, right? And how we need to deal with the issues and the problems that we'll face in the future.
Yes. Yes. Well, just as a final statement, I think we are occupying a special place in the universe at a especially critical time, and to ensure that we thrive and flourish and don't become extinct ensures that we need to use technology wisely and avoid the risks and deploy the benefits. And in making those choices of how we use technology, we've got to use a system of values which science itself can't provide.
And all this can happen if we are able to select, I think, also good policymakers, that they understand the grounds of it, right?
Well, that's right. I mean, we've got to ensure that the politicians make the right decisions. But of course, politicians respond to the voters, and they will only make these decisions if the voters are behind them. And I think one important point is to make sure that the wide public is mindful of these long-term threats to the planet and these long-term issues. And that's why I think well, scientists obviously can do their bit to get through to the public, but we depend even more on charismatic figures. And I'd like to mention four very different people who've had a big effect in the last few years. One is Pope Francis, the other is David Attenborough, the other is Bill Gates, and the other is Greta Thunberg. These are four people, all very different from each other, but I think they have all made the public more widely aware of the dangers of uncontrolled climate change, and I think that has been a definite plus, and that means that politicians will take these issues a bit more seriously. But we've got to keep banging on about these concerns, because in a world where there's so many urgent worries, there's a tendency that these long-term issues drop too far down the agenda.
Yes, and also thanks to you sharing, this information, bringing. I mean, it was fascinating for me to read your book, which brought cosmology, physics in the picture.
Yes,
I could see, I could fit humanity in this bigger
yes,
picture and understand the issues that we are facing,
yes, yes,
and thinking of humanity in this bigger scale, I think that also
Yes.
is important for
Indeed.
all the people to think that how they can make difference in this
Absolutely.
life.
Yes. Yes.
So thank you so much for
Well,
giving
thank
me
you very
time.
much. So it's very
This
good to be
was
in touch.
really
Yes.
great. Thank you.
Good.